Hello everyone, this is Dr. S. Nagini, Professor, Department of CSE, VNR, VJEC. Today our topic of discussion is file handling in C language. So we'll just browse through the index, what are the topics that I'll be covering up. And we'll do it in small phases so that it will be very clear to you. Yeah. These are the topics for discussion. We would like to go ahead with introduction about what is a file and what all operations you can do on files and how files are stored and how to understand where the file ends, that is the end of file marker. And we will also discuss about types of files, that is text files and binary files. And we will understand what is exactly this file is, which is written in the capital form here. And later we'll discuss what are the various file streams that we'll be working on. So we'll just carry ahead with the introduction, like what is a file? Usually what is the file? When we discuss about files, we store various types of files, like we organize our data, we'll organize our Word documents, we'll organize our PPTs, we'll organize things in terms of music files, movie files, etc. So that's where the beginning starts. We just call a file as a named collection of data stored in secondary storage. Now we also see files which have both video files, text files, as well as movie files, everything together into a single file also. The reason behind of creating a file is we want to access it at a later stage. Hence, we wanted to do it as a permanent storage. That's why we were discussing a point on to store data permanently in a secondary storage. And I hope people know that when you store your data, it isn't always done in the secondary storage. But when you're working on your files, it is done in the RAM space only. So your workspace remains RAM, but the moment you say store and you want to make it permanent, it is stored in the secondary storage. The purpose of doing so is it helps us to retrieve for further accessing, for further modification, even after closing the file today, tomorrow, or any other day in the near future, you can still access the files. And the data stored in the secondary storage secondary storage always exist in terms of files only. And these files, based on the type of data that you're going to use, it will be stored in the form of blocks. So here are certain examples that I would like to discuss. Records of all employees in an organization, where the organization stores, they are usually stored in the form of files. For example, even if I take about the students, if a student database, if it is maintained in the college, it is existing in the type of file called as a database file. And we also have a lot of Word document files where we store our text, where we store our papers if we are going to publish, and we store all other information for our day-to-day activities for whenever you're coming across teaching learning process or in any organization, they keep using a Word file for information exchange. And apart from this, we also have video files, video of any movie, video of right now we were discussing about files. It is again created as a video. It still exists in the form of files. And we also have audio files. If I just remove the video from this and then project my audio, it becomes an audio file. So these are a sample various types of files. Other than this, probably you might have seen PPT files, Excel files. These all come under different types of files. Usually what is the purpose of creating files? Basically I want to store data for which we will be opening files. So these are come under operations on files. We can open a file. For this we have to create a file, and for which we have listed the create a file option. And then once you create the file, we can open it for various operations. Like if already some data is existing, we want to just modify the content or update the content of an existing file, we do an update operation. We do an append operation, already data is there, but I want to add more data only at the end of the file, we perform an append operation. We do delete. If you don't like the file, we do a delete operation on the file. And we also write content into a file. On an existing file, we write content. On opening, we can create information in this. We can simply read a file, and we can, after doing all these operations, we can close a file. These are a set of operations that we can carry out on files, and just listing the operations: open, create, update, delete, write, append, read, and close. These are certain operations that you can carry out on files. And how exactly are these files stored? And how will you understand the file is going to end? So here we can just see that the file is stored as a sequence of bytes. For example, I'm just listing out to you. In a secondary storage area, if you treat this as a secondary hard disk, your files are stored in the form of blocks. Now the block size depends on, it is usually a power of 2, and it's usually defined by OS. And probably in this you will start storing your file content. And this is stored in the form of bytes. It's stored in the form of bytes, and usually they are contiguous in nature. Contiguous is the data is stored adjacent to each other previous data. This is a logical contiguity. It may exist contiguously on the disk or may not exist contiguously on the disk. This content of understanding how it is stored and all, most often it is related to another subject called as an operating system. But the data for us, it is logically contiguous, but it may not be physically contiguous on the disk. The last byte, how will you understand that this is the end of the file, or this is the last byte after which the file content is not existing? Then it is always marked with what is called as EOF, an end of file marker, with an ASCII value of 1A, which is an hexadecimal value. The end of file marker is a special marker that indicates it's an end of file, and it is typically used in file handling operations to detect when there is no more data to read from the file. For this purpose, we go and address end of file. And what is this end of file? It's a macro in C, and it is defined in stdio.h, standard input output header file. For example, if I create a file, let me say this is file xyz.txt, a text file, and in which I have written I am at VNR VJEC, at VNR, and we are opening this file probably in a read mode. So this is an operation that you're going to perform. This is one of the operations that I have listed early. Then we start reading the content from I and follow up to AM at VNR. After this, it should not retrieve further data. This is where the end of file mark is stored, which is invisible but hidden by the file as end of this file. So it will not be reading beyond this marker. That's about your end of file. Just a consolidation on top of this, files are stored in a sequence of bytes, and we recognize while going through a file, we have reached the end of file using an EOF, which is a macro, and it is already predefined macro in stdio.h. And while reading text files or binary files on any files, we reach about this end of file marker. So this is all how files are stored and how end of file works. Now these are the various types of files we were discussing in the beginning also. We come across various types of files. So usually files are categorized into two types. One is text files and the other type is binary files. Text files, most often they have characters. Typically whatever is there in your keyboard, every character you can place it here. It can be numbers, it can be alphabets, it can be any hyphens, dots, other special characters, anything. And everything is encoded and stored in an ASCII format. This is very important for you, that it is encoded into an ASCII format and stored in a byte sequence forms. Text files store data as a sequence of characters, and this character is like a byte sequence with lines separated by a new line. That is /n is an escape sequence character which will help you to move to the next line and which will help you to identify that the remaining data is in the next line. That's how the entire text file is stored, and at the end you will be having the end of file marker. For example, I'm just taking ahead. If I am writing I am at VNR, so here the /n will be hidden. It will not be shown to you, but it understands the data is supposed to be read from the next line in the file. And here we have an end of file marker. These you will not be seeing on the screen, but these are the escape sequences which help you to work with the files when it moves to the new line and all, and when the file reaches end of file marker. So coming to what are the various text files that we go ahead with, we have plain text files. Most often, how do you identify various types of plain text files? It is based on the extension. For example, if I create a file, file1 .txt, this is the name of the file that you are going to give, and this would be the extension. Extension tells us what is the type of the file. So .txt is helps you to store text files. .doc also for text files. .docx as another text files. Like this, you might have been storing files in various other extensions. Now coming to storing data in a tabular format, when you are going to store, you have comma separated variables, comma, XLS files, that is Excel files. These all you come under Excel files as well as CSV files. And you also have HTML files which help you to create your web pages. So they contain structured text for web pages, and they have an extension of .html. And apart from this, if you are coming across any programming language, all of them are source code files, but usually they are treated as text files. And you see the source codes. For example, C files are stored with an extension of .c, C++ files are stored with an extension of .cpp, and Python programs are stored with .py and .java for Java files. So these all come under source code files of any programming language. Then comes our binary files. These are stored majorly in machine readable formats. And when I say it is in machine readable formats, they are in zeros and ones combinations, whereas text files are usually in human readable format. And all the machine readable formats are examples. You can store numbers, images, audios, videos, and they are stored in a very compact and an efficient way using zeros and ones combinations. And for example, image files have an extension of .jpg, .png, .bmp like this, and audio files will have .mp3, .wav files. If you are a music lover, you will be creating a folder and you will be storing all mp3 music files under the folders. Similarly, all video files are stored in the form of .mp4, .avi. All the executable code of your source code files, like the programming codes, once you create an executable version, they are stored using .exe. We see that in our mobiles, the Play Store contains all .exe files, all executable versions only. And also you have .bin files, and all database files you have with .db and .dat. So these are the various types of text files and binary files on which you will be working, will be doing some operations over a long time. Now, what is this capital FILE? Capital FILE, this is the one which helps us to access files, and this comes under a defined data type. Now, when I say it is defined in nature, there is a pre-built information in the form of a structure. Now, a structure is a one which holds different data types. So it is predefined in a standard library that is used to represent a file or a stream When I say a file or a stream, am I doing the file operations on the screen, or am I doing it through the keyboard? Am I sending it to the printer? That's where we talk about streams. And it's actually an abstract data type for handling files in C. Now, what exactly this file structure contains? It contains all meta information and all buffers that you require to perform file I/O operations. So, for example, you can see where is the current position in a file. If you would like to know where is your how far you have worked and where are you exactly located, we use the current position in the buffer. And how many number of bytes you have already done, how many more bytes you are supposed to read. This you can see through the number of bytes left, and this is a point towards the initial buffer. And a lot of flags are raised while reading. Different flag is raised. The purpose of reading, when we raise a flag for reading, we cannot perform a write operation. So different flags are raised on a file based on which these flags are enabled. They may take different values. I just list out. If I say the flag takes 0, probably you can do a read operation. If I say the flag takes a value 1, you can perform a write operation. If I have another combination of 0 and 0, probably I can do both read and write. Like this, different flag values will be raised. And when it comes to working with files, enter where it should store and how to retrieve it, it all is handled by operating system. And hence the operating system will be taking the help of this file descriptor. And even you can read the data, you can understand what is the size of the file, and all this information are pre-restored in the structure. As and when you open the file, the data about that file gets stored. So initially we only store the metadata, or as and when the file you create and all, the complete information about that file is restored. And further, it is the role of an operating system to take care of storing the file, to addressing the file and all this. That's how, for example, if you list and open any file, you will be getting, say, for example, file.txt is having some 32 bytes, and probably it is opened on this 22nd of 7 and 25 at 11 a.m., something like this. All this meta information you will be coming across when you just look at file. Only little of information is shown, but beyond this, there's a lot more information that is hidden, and it is hidden in this structure. So this is the idea behind file. Using this capital F-I-L-E, we define, we try to create a pointers. Say when I open a file like this, and I want to create file 1.txt, and I want the starting address of this file in some F. So this F will contain address. Hence, it is an address towards a file pointer. And using capital F-I-L-E, we define the file pointer as star F. So this capital F-I-L-E is a defined data types which help us to create file pointers to work on the files, to carry out operations on the files like read, write, open, close, append, and update. So these are the various file streams which you will be working in. Whenever you want to give input, we usually give it through the keyboard. The keyboard default file pointer is stdin. You need not define using capital F-I-L-E as star stdin. This is not required. This we don't require it because it is a predefined file pointer that whenever it is stdin, that means you are taking the data from the keyboard. And similarly, when it is you are trying to print something on the screen, we define it using stdout, a default file pointer. And while working with files, you come across various types of errors, like you're trying to read beyond end of file, or you are trying to read content from a corrupted file, or you are actually opened a file for one purpose and you're trying to do another operation on this. For example, I open a file for reading, but you try to write onto that, then it's an error. All such sort of errors are handled by a default file pointer called std error. So these are the various file streams which we will be coming across over a time while learning more about files. So that comes to the end of the first part of the basic idea about how the files exist, where they are stored, how we access, how are the various types of files, and what are the various file streams. Thank you so much. We'll go ahead for the next topic.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.